me fix my screen real quick. Okay. All right. Let's go over everything that we just did. Okay? Those of you that are out or those of you that are watching online, we are here. Okay, Thursday, I'm gonna move it back. Thursday, we worked on this. Okay? One variable was isolated. Today, we're doing number 2, which is just one extra step. No equation is set equal to a variable. You got to move it over. So we have 2 equations. We fixed the second one because y has no coefficient. It's all by itself. And then we did the work. So we were in the no today. We moved the equation around, then we went back here. Okay. Remember, let's go back to the title of this lesson. Okay, give me 5 more minutes and I'm done. Solving. I'm going to go word by word. This has got to make sense. What does solving mean? Jake, if I say solve, what does that mean?
To find the solution.
Find the solution. Perfect. Nick, what does systems mean? Or more specifically, if I give you a systems of linear equations, how many am I talking about today?
2.
Okay. 1, 2. Y'all remember that? Okay. Kaylee, what is linear equation? If I say graph the linear equation, that simply means graph this blank line. Do you see the word in linear? Okay.
Yep.
By substitution. What does substitution mean in your own words? Anna, I know you've been out, but I want you to try and figure substitution. You're picking up a term and what are you doing with it? Right. You're replacing it with something that is equal. Okay. Here, the only thing we had to do here was move the 3x over. Y is isolated. I'm going to circle this. I'm going to star it. Star all the above. That's the only extra step. Okay. Before I move on, I want you to look. I'll come back to this. Look at this system, right? How many equations do we have? 2. This is called a system. Look at this set. We just did this one, right? Yeah, we just did that one. Now let's look at this one. Is there a variable isolated? Yes or no? No. Can we make it that way?
Yes.
The first equation, in my opinion, is easier. Y'all agree? Okay. Does it matter, X or Y? Because neither one have a number, right? It doesn't matter. We'll do this one in a second, but that's what I need you to that's the difference. Guys, look at the second set here. What do you notice about both of these? They're both isolated, okay? That's the easiest one. Remember I said the third situation's the easiest? Okay, I'm doing that last, all right? Now, let's do one more. Oh, the most obvious thing. Going up to here. Here's where we got 4, -1. Somebody tell me, what does this mean? Tyler.
On a graph, we put that, and that would be your first one.
Okay, you're on the right track. I want a little more specifics. I'm going back to these 2 equations. Yes, ma'am. Okay, this is our solution, right? What does that mean? It's the answer. What does that mean? If I graph these 2 lines, what does this point?
Oh, that's what will hit.
That's where they'll intersect. Okay, good. So if I graph these 2 lines here, okay, remember y equals mx plus b. We're not doing that today. Okay, that was 6-1. Okay, if I graph these 2 lines, they're going to intersect at 4, -1. So that's the difference in solving. Okay, Now, let me give you one more example. X plus y equals -5. 4x minus 5y equals -20. Is there a variable isolated? Yes or no?
No.
No. So let's go to the no side. Here we go. Raise your hand if you want to isolate x. Y. Who likes x or y? Y'all pick. I just heard x first, so we're going to do that. Again, why does it matter on this equation? It doesn't, but why?
You just subtract it right there.
Right. So I'm going to choose x plus y equals -5. You're going to choose the easiest to isolate. I'm going to say x equals -y plus -5. Someone tell me, why is my y negative? Why is the y negative?
The x can't be.
Anna's right. Say it again.
The x can't be negative. It's the a.
Well, I'm isolating the x. The x needs to be by itself, so I have to move the y over. When I moved this y over, it became negative. So there's our new equation. So now I'm going to use 4x minus 5y equals -20. And we are going to substitute x for our new value. 4, times -y plus 5 minus 5y equals -20. I'm going to let y'all do the math, okay? I want you to recognize, be careful right here. Why am I saying be careful? Where can we sometimes make mistakes? The negative? Okay, watch your math. All right, I want you to work on it by yourself. And see where we go. Quick refresher, and we'll repeat this again. We have two lines that we're not graphing, but we're solving algebraically using substitution. So as you're working, I'm going to write my work up here. No. We're getting a fraction?
I didn't.
The 20s are supposed to turn out to a 0 because
It's negative.
it's -20 plus a +20.
No? Oh, whoa, I forgot a sign. You're right. All right. I didn't write the problem right. So that's a negative. That's a -20. So I'm adding 20 here. Thank you. I knew something went right. There we go. Okay. I fixed it right. -20 plus 20. That's negative. So I'm adding 20. Okay. Divide by -9. I get 0. Okay. As you can see, it's easy to make a mistake. So we found y. What do we need to find now? X. I'm going to use the easier equation here. The first one, again, it doesn't matter. x plus 0 equals -5. X simply is equal to -5. And there we go.
Hey.
Did you get it right?
Easy.
Okay. I have one more problem, and it's the third situation. I'm going to let you catch up and fix this. We substitute 2 times. We substitute in step 2 and step 3. All right? Step 2 is by far the most important. A lot of work here. Okay? So if I graph these 2 lines, they're going to intersect at what point?
-5, 0.
-5, 0. Okay? All right. I have one more example, and I'm only doing one because it's that simple. Okay? All right. Can I move this? I'll come back to that. All right. Situation 1, we've done. Situation 2, we just did. Situation 3 is, I think it's just more funner, whatever grammar is the right
That's the
grammar.
wrong word.
So everybody look and see, situation 3, y equals x plus 5, y equals -x plus 3. Therefore, you're going to set these equal to each other and solve, okay? So let me give you an example, and then I'm going to let y'all do some classwork by yourself, okay? Can I move this? Okay. This is that. This is that. Order. Okay. Okay. They're both equal to what variable? X. X is isolated twice. So this is situation number 3. So you're going to say 3y minus 6 equals y plus 2. Variables on both sides. It's been a while since we did this. Quick reminder, you need all the y's on one side, and I need all the numbers on the other. Okay, so I'm going to move this y over. Do y'all remember this?
Yes.
2y minus 6 equals 2. Now I'm going to add 6. 2y equals 8. Divide by 2, divide by 2. Y is equal to 4. I found y. How do I find x? Now choose either equation and substitute. X equals 3 times 4 minus 6. 12 minus 6, so therefore x is equal to 6. So the answer is 6, 4. You just set them equal. All right, Reagan's going to pass out your classwork. Guys, I'm telling you, this has to be done by 9:50. Okay? You need to work. This is not social time. This is part of your studying. Okay? All right. I caution, don't get too alarmed. You're only doing 11 problems. Looks like a lot more than it is. Okay?
Yeah.
Thank you. Okay. let's look at, everybody have a maze sheet. All right, everybody, Alex, put it up. Where do you think we start? Wow, y'all are so smart. I love it. Okay, we have two linear equations. Just a reminder, if I graph these two linear equations, they will be what? Lines, right? We're trying to find where they're going to intersect. All right, look. What situation does these systems fall in? 1, 2, or 3?
2, 1.
But they're oh, wait, no.
But it's not equal to this.
I said never
All
mind.
right, do y'all see why it's situation 1? Okay. So, you're going to take 2y minus 4 and put it here. Okay. Now, on this sheet, you will have all 3 situations, I think. Yeah, you should. What we're going to do is I'm going to do this first one with you. Everybody turn your paper over. Look what you have.
Show your work.
All right. So here is our work. X equals 2y. I'm sorry if you can't see it. Give me 1 second. Now, this may get a little crowded. And that is a really messy 8. Don't know what happened there. So I am going to write as small as I can, but write as much as I can. So I have 2y minus 4 plus 8y equals 16. I have 10 y's. Where did I get the 10? Two y and 8y, okay? Add 4. 10y equals 20. Y is equal to 2. So I'm going to now go up here. This is where it's going to get a little messy. I'm going to use the first equation, but again, it doesn't matter. X equals 2 times 2 minus 4. I get x is 0. All right, so here, this is our solution. I'm going to turn the paper over. Here's my answer right here. Do y'all see how it's 0, 2 and not 2, 0? Okay, so you're going to go this way. Okay, please watch me because I want to make sure you're doing the right problems. So you're going to do this problem. You're not going here. So in fact, if you want, you can lightly X this one, if that helps you. You now have 10 problems left. I'm telling you, there's only 10 more left. You're going to do this problem. What situation does this one fall under? 1, 2, or 3?
This one is 3.
This one is 3. Okay, X plus 3 equals 2x plus 5. Solve for X, get your X, and then find Y. Okay, I'm going to let y'all work. Okay, I do have a favor. Please make sure, you might want to use a colored pencil or highlighter. You see how I've used a different color? Because this has a lot going on. Okay, so I want to make sure you are going the right way. All right, so I'm going to leave that up. Bless you. And I'm going to pause the video.